So this is the most fun session here of the entire conference. You guys are privileged to be in actually the most exciting session. And we're going to destroy things. We have a suitably dangerous piece of equipment there. You can see Alex is wearing his protective equipment for a reason. Yeah. Well, actually, if you notice, we're cutting acrylic plastic, so we don't get any fine particles and sawdust. But if we were cutting wood, or we were cutting a more toxic substance like MDF, we would definitely want a respirator in the building. So we've chosen a suitably conference-safe material to print here. But that is, if you do this own work at home, you seem like you might know something about the CNC cutters, sir. Just a wee bit, okay. Do you have proper ventilation in your shop?
I have a shop vac.
Shop vac.
I do also have a respirator, so.
Okay, very good. So you have personal safety taken care of. So we did this experience at Java 1, the HearingNest Start experience. And basically the idea here is that attendees got to do different experiences where they would interact with art and create art at the conference. So we had a German artist, Mirja Wellman, and these are her hearing helmets that she designed. You put these on and you can hear her yourself. All of her artwork's about hearing. And she also designed this beautiful sculpture out of the items which were printed from the CNC cutters at the event. So here are some examples. Hey, welcome to the talk. Here are some examples of things which were printed at the Java 1 conference and then constructed in this huge geometric sculpture, which we created. They were all cut out on a series of carbide 3D routers. So we had about 4 of these running at Java 1, 2 of them running at OpenWorld. And then you can see here one of the cuts in action. So this is a nice little Java Duke being cut out on the CNC router real time. The way this worked for attendees is they could either draw on the touch screen, which Alex is setting up, or they could do it on their mobile app using the Code Lounge application, which is an app written in JavaFX using the Gluon framework. Then they draw on the screen, submit a code, and it gives them back a little QR code. And then the device here would use a QR code scanner, essentially a Raspberry Pi camera, and then print it out on the CNC cutter. And the backend was using the Oracle Cloud. So we had an Oracle Cloud backend service, which was a REST API, which would, you would send the drawing to the REST API, register it with the service, get back a code, and then you could print that off the CNC cutter. Here's the CNC cutter in my garage, really early prototype. You remember this, Alex? The horrible UI? It's slightly better now. Yeah. Slightly less horrible. And we're using Raspberry Pis to actually drive the screens, run the UI, and also drive the CNC cutter by sending Grble to the CNC cutter, GRBL. For running stuff on the Raspberry Pi, if you haven't done this before, it's really easy to run Java on the Raspberry Pi. If you use NetBeans, there is actually support for remote running on the Raspberry Pi. So you set the host IP address, your username, password, the JRE path, and then you can directly execute code on the Raspberry Pi from your desktop computer. So it's a really quick and easy way to run stuff on the Raspberry Pi and test it out. And a little bit about the CNC cutter. So we're using CNC cutters from Carbide 3D. The nice thing about this model is it uses all brushless DC motors, and it's relatively quiet. So you can run it indoors. You could have it on your desk next to your computer. It's not going to make too much noise. A lot less noise than your CNC cutter, right, Bob? Yes. And it can cut reasonably hard materials. So you can cut plastic, wood, soft metals like aluminum. You wouldn't want to kind of think more rigid than that because the CNC cutter is not designed for super industrial purposes. But for prototyping, designing, doing little 3D structures with CNC cutting, it's quite nice. And it's much, much faster than 3D printing or other fabrication methods. So Alex is going to talk a little bit about how you calculate the Workplane offset and how we wrote the code to get the CNC cutter working. Do you want to use the mic here or the handheld mic? That one's not actually on.
That was on?
It's not on. You have to use this one.
Hello? It's not on as well.
There you go.
Hello. Okay, so welcome to the talk. I guess Stephen gave a good introduction to this, and I'm going to talk about more technical details. Okay. So, so how many of you actually played with the CNC cutter? I guess it's better. Just one. Okay, good. So, it's nice, right? It's fun. Did you use Java at all?
I'm working on using Java with it. So
Oh, okay. What do you use?
I want to build, what am I using currently? I'm using Chili Pepper to send my GCode.
Uh-huh.
And I want to write a JavaFX front end that'll handle all of that for me and do some basic machining operations.
Wow, nice. Almost what we did with this in this demo.
Yeah, you and Bob are going to be friends.
Okay. Okay, so good. Yeah, so exactly, I mean, in this demo we did exactly the same. We were controlling CNC cutter machine from the JavaFX app using Java libraries. And yeah, so that Raspberry Pi over there actually does that job. And we'll show the demo soonish. So coming back to slides, calculating the Workplane offset. That's a technical part, but basically what it means is that a CNC cutter machine operates in two coordinate systems, and one is pretty much attached to the the CNC cutter itself, and another is the piece of plastic that you're trying to work on. So you need somehow synchronize those two systems. So, so machine coordinates are here on the bottom. Do you see my? Okay, just give me this.
Center button.
This one. This is the machine coordinates. So, what's nice about machine coordinates is that those are though they have a reference point. So inside the device, if you look over here, like in the right backward top corner, there is a set of switches. So can you turn it off and turn it on? So what it does when it's turned on, it tries to find that point. So it moves to the to the right sensor, then to the top sensor, then to the back sensor, and that sets the 0 position in machine coordinates. Then the trick is that the piece of plastic that we are cutting is on the other end of the coordinate system. It's over here. So how we get to there? And this particular model has this nice thing called the tool length measuring sensor, something like that. So the idea, if you look at that in action, it was actually going down to touch the sensor and to measure the length of the tool to set up the coordinate system. And then you use that data as an offset for the work coordinates. And as I shown in the slide here, work coordinates usually start somewhere on the piece of plastic you want to cut, and those coordinates are usually positive. So how do we do this? If you buy this CNC cutter from the store, will come up here with there will be a piece of software provided to do that. And if you only using some GCode sender, software of your own, or you develop it yourself, then the trick is how to figure out the correct sequence to perform the same measurement steps. So what I did is I actually sneaked into the protocol and just collected the commands as the official software was running, and then just guessed what they were doing. And here is the sequence that is actually used. So it starts with some initialization, and then it positions. So with the let me take a look. Yeah, it's positioned so with the over the place on the board where the the sensor is, and then moves down fast first, then slows down, and
Yeah, so this is your path code.
oops.
This isn't the initialization code.
Sorry.
That's fine. I think I deleted your initialization code.
Okay,
But-
good joke.
But basically, we recreated the initialization code to do exactly the same startup sequence where it goes, moves, probes, goes down, touches the sensor, comes back. And it's the same sort of G-code you can see here. This is the G-code that does the equivalent logic for going from point to point on the cutout steps. So it sets the spindle speed, goes through each path segment, moves to the next point, and then it sends each of the commands on the left, but the right side is a human readable form of that.
Okay, so thanks, Steven, for killing the slide. Okay, let's move on. So basically, I can explain the same thing again. It's just a number of commands that set the speed at which the bit is approaching the sensor, and it slows down, and it tries to attempt to measure as precise as possible. And then once it's done, there is a set of X, Y, Z coordinates that you can use to offset, and it will always be the same offset from the position on the plane where you cut the piece. So okay, that was on that slide. So yeah, next thing is just G-code. So for those who do not know much about it, it's a simple, very basic format of how the a CSC cutter could be controlled. So usually it's X, Y, Z coordinates and some command associated with it. So yeah, in this example, G0 is rapid positioning thing. Then G1 is linear interpolation, and F specifies the feed, like the speed of the movement. So it always moves from the previous point to the next one. And then, what else is here?
So here's an interesting fact about G-code. So back when it was created, like, it was maybe the 70s, 80s, really early, around the same time when computer languages were coming out. So they actually designed G-code to be a full language with variables and control structures. And actually, if you look at the full G-code specification, you can do a lot with G-code. In practice, none of the machines today support that, because most of the machines, they have a dumb controller which is doing the G-code controlling, and you'll use higher level programming languages or like GUIs or even modeling software to generate the G-code. So G-code is in its modern form is mostly just machine instructions for the motors at a very simple level. But originally, I think they had grander aspirations for G-code, people actually manually writing G-code and designing this and maintaining G-code as a language. But in practice, most of the machines don't support the full G-code spec anymore. They'll just support a limited set of operations for direct point-to-point. Even like complex things like spline curves and other stuff, a lot of the machines don't support. I think this doesn't support spline curves, but you can approximate it by doing linear paths and other things.
It definitely supports circular shapes.
It supports
I'm not
arcs,
sure
but
about
not
those.
splines.
I didn't try those. So yeah. Yeah, so yeah, you're right. So G-code is these days is just, set of coordinates, and it could be very, very verbose and not human readable at all. Although you can always read it, but hard to understand what's going on. So in order to communicate with the CNC cutter, I used the Universal G-code Sender software, and that's open source project available somewhere on the GitHub, I guess. So it has a number of commands in the API that you can use, and I was pretty much just queuing commands like these G-code commands that we were talking about, and that's it, pretty much. So.
Well, you also fixed some bugs for them too.
Yeah.
They had some threading issues and other bugs in the code.
Yeah, I should. Yeah, I didn't want to put attention to that, but I should say that the code is not super high quality, so expect things to not work out of the box sometimes. Yeah, so, but the good part is that the project is still in development, so they develop new versions and you can participate, I guess. Okay, so the next part, so Steven deleted a lot of slides, but basically these are the only slides that we're covering how we control the CNC cutter, I guess. What I've done is I pretty much wrapped all the commands that you can possibly want to do with the router, like move to this position, cut up to there. I wrapped all of these into API and then just produce GCode and send it using this GCode sender thing. So the next question that comes into picture is what to cut. And the plan that we had, it was to draw something on a screen and then somehow make commands for the for the CNC cutter out of it. So the good part is that like if you look here, all you pretty much need to know is XY coordinates of a shape, and that has a really good mapping to Java 2D shapes. Like Java 2D shapes have these line 2, move 2 parts, and I just map those to the commands to the machine. So the only question was what exactly we want to cut. So
and just to set context on it, like I drew an example there, but the way we were doing these cutouts is we wanted an outline that we could give to the artist. So whenever you draw something, it always traces your finger, and that outline part is what we give to the artist, and it has to have no overlapping lines or any odd shapes in it. The center part is what we gave people to keep as a badge at the conference. So the white area in the center is what folks got to take with them, and we would cut a hole in it, and we would let them write things on it, and they could carry that around as a badge for participation in the project.
Okay, so this slide shows two things that I had to fix, to solve when I was developing this software. And one is that if you have curves in your path, like Java 2D supports cubic curves, like arcs and other like Bezier curves. Mm-hmm. So fortunately there is a easy way to solve that, and you just invoke this get path iterator with null and flatness value, and it will basically replace all the curves with a move to line 2 segments. So no longer need to support curves on the device. And then if you have an SVG path, or if I have an SVG path, this is not obvious, but this actually produces the outline of the SVG path. That's the API, Java 2D API, I guess. So whenever a person draws something on the screen of on the touch screen of the device over there, we get something like this, a number of segments of line 2 things. What we want to do instead is to get to shapes, one around and one inside. So the way to get this is to actually draw this shape with a wider stroke, and then find its outline, and then just follow the outline and cut it. So the question is, what's wrong here? So let me add more context. So what 1/8 here, 1/8 is the width of the bit that we use to cut, and 3/8 is the width of the shape we want to produce. Do you have an example of shape?
Yeah.
It's over there, I guess. Steven, in the box.
Okay.
Yeah, something like that. So that was our goal, to cut shapes like that when a person just draws a heart. So, yeah, so what's wrong here? Steve, can you think about?
That doesn't look like a circle. What's with that bottom right point? That's broken. Your code is broken.
What's broken around here? Any guesses? Exactly.
Oh, okay. So our CNC expert got it.
So yeah, that's the true answer. So yeah, we cannot cut the parts that are smaller than the drill bit. So anytime a person draws a sharp corner like that, we can only approximate to it. So we won't get those perfect shapes that people want. So how can you do that in Java? Again, you draw this, you draw that. What's the code for that? Okay, so Java 2D version of this code. So you get a path 2D. You select a stroke. You specify that you want a round corners, good joints, round joints. You create a shape. You create an area out of shape. And then you get path iterator of that area. And that's actually your outline. I actually had, I wasn't able to find this from the Java doc. I had to ask an expert in Java 2D to actually figure out how to do that.
But you happened to sit nearby some Java 2D expert.
Yes, that was the lucky part.
It was Brian Beck helped us?
Phil Race, I guess.
Was it Phil? Okay.
Yeah. So somehow if you get path iterator for the area, you get the outline of the area. So, but unfortunately, that algorithm they have in Java has bugs. So if you look here, the artifact, here, oh no, sorry, not there, over there, yeah. So this looks like like it's a cow. It's supposed to be a dog, but it looks like a cow. But actually, it should be just round corner over here. So and here it kind of fits into the the idea of a man with a nose, but
yeah,
but it was not something that people were actually wanted to draw and cut. So I had to invent something different. I ended up downloading ESRI geometry library from GitHub, and they have a much more obvious API. So you have the boundary operator, and you just provide the shape to it, and it can generate you the polyline around that shape, and that actually works, and it's used in this demo. It's a little bit less performant because they kind of try to cover all the edge cases, etc. But yeah, that's how I do it. And then we go. Actually, that finishes the problems that I was facing in order to cut this. Do you remember anything else to talk about?
I remember we had some threading issues with homing procedure.
Yeah,
that once we fixed those, then it was more reliable. And in general, these CNC cutters seem to occasionally fail, but restarting them always fixes it. So sometimes they get stuck in weird states, like you'll get error codes back during initialization or other stuff, and you just restart and it's happy.
Yeah, so what I remember about that is that it's actually the code that was communicating with a router. It had several layers, like caching layers, and different threads writing to the outgoing buffer and reading from it. And there were some threading issues, like like it was assuming the state has changed, but it actually didn't change and stuff like that. Or for example,
Oh, I remember something else. Didn't we have to turn off the caching entirely?
Yeah, exactly. That's why we had to turn it off, because there were issues with that.
Yeah.
And I guess another thing was that there was a notification handler when you send a command. Once it's executed, there is a handler that's invoked. But if you ask the controller, the universal sender, about the current state, it's still not like completed. So it kind of updates you that the action was done, but it still thinks it's not done. So if you ask it to do more, it will just fail. So several things like that happened there, and I guess that's one of the places when I fixed it to send the notification after they update their initial state or something like that.
Mm-hmm.
And
okay, and last thing is the QR code reading.
yeah, but other than that, I guess everything else was pretty straightforward.
Yeah, no, I think overall it worked pretty seamlessly. I mean, we were running these all week at Java 1, and most of the issues we had were mechanical issues with the machines, like the limit switches getting out of position. The software worked pretty well. I think on a couple machines, the serial port randomly changed on the Raspberry Pi for a reason we never quite determined.
Yeah.
But there's a property file for the code to set the serial port, so if we just modified that to pick the new serial port, which the Raspberry Pi, which the Arduino in the CNC cutter was picking up from the Raspberry Pi, then it worked again until you rebooted it, and then it went back to the original serial port. Quirky stuff. Okay, so.
QR code reader.
QR code.
So this is, yeah, something
that's the little, what we use the little camera for up here. So you can choose scan QR code, and then if you're using the mobile app, you can scan with the little camera here, and it will do its thing.
So in order to do that, there is a nice library which is called JRPI Cam. And that's, again, pretty straightforward. You just, ask it to take a picture, and it takes it. And what you do next is that there is a ZXSync library that is capable of parsing QR codes out of the image. So you pretty much just gives it an image, and it decodes it into a QR code. And then the tricky part is that you continue to get new images until you get something reasonable from the QR code scanner parser. And I guess that's it, and we turn on to the demo.
Okay, so question, Bob.
Regarding the QR codes, was that actually passing like an SVG representation of the graphic, or was that just a key to some data store?
There was a key. We actually, Steven mentioned that we actually had a cloud backend that stored all the SVG paths there. So if you put the whole SVG path into QR code, it won't be recognizable. It will have a lot of small, dots in it.
Yeah. We did consider doing that, but it's too much data for a QR code to be read reliably by the scanner.
Yeah, I actually asked them to remove everything but the ID, so that it's big and easy to scan, and then I just add the the URL to it. So they started the
originally it had the full URL prefix, and then the code's longer, and it's a more complex graphic, and it's harder to scan. Okay, cool. So we're gonna do a demo. So you guys should come up here. Since we are done with the slides, we're gonna cut the mics. Consider the recording over now. And you guys can feel free to ask questions as well when you come up. So who wants to do the
Do we
drawing?
have a code available somewhere? I guess we do. I'm not sure. Oh, it's an open source, right?
Yeah.
So the good part about this code is it's all in open source. We didn't cover a lot of details, but you can get an idea by looking at it.